Okay.
Yeah.
So.
That's what you told me in my car.
I said sometimes in my car.
In my car.
Not all the time.
Maddie does it too. It's not just me.
Yeah, but I know.
Okay.
You really did.
Somebody.
It's okay, we're happy.
8? Can I teach number 8?
I think I'm going to go, as much as I appreciate the offer.
Oh, okay. That's when Roger sings.
Is that the first one?
No, Dante says baby.
And Heather Hill says no. What is her problem? He's so hot.
Is that Heather Hill's Sweet 16 party? He's so hot. Oh my gosh, I'm gonna watch a movie tonight. And then take a video and do something party. And then the kids will be like, who's Cynthia?
Okay, so guys, let's talk about these. So in number 8, we have to first distribute to each of these parentheses. So when you do power to a power, you have to multiply. So this is n to the 4th, and then this is n to the negative 4th when I multiply. Then now that I'm multiplying these, now we have to add our exponents. So I'm adding those two together. So 4 minus 4 is 0. So there is no n to the 0 we have here, which is just equal to 1.
I could have taught that better, but.
Okay, yeah, thanks.
Oh.
Okay,
Oh.
so going down to number 16 or 14 here. Now there's a couple of things we can do first. You can simplify inside the parentheses first. Do you want to do that? I think we should. So we can simplify inside first. So negative 6y to the 5th over 3y to the 2nd. So negative 6 over 3 becomes what?
Negative 2.
Negative 2. Y to the 5th over y squared. There's 5 on top, 2 on the bottom, so
Y30.
y to the 3rd on top. There really would be nothing on the bottom, so I don't need to really write that quite yet. So now this is going to get distributed into both of these. So this will become negative 2 to the negative 2. Y, power to a power, you multiply. Now these both have negative exponents. When they have negative exponents, we need to switch their position in the fraction. So these are currently on top, so we're going to move them both to the bottom. So now they're both on the bottom. And I can do negative 2 to the 2nd. Negative 2 times negative 2 is a positive 4. So this is going to end up just staying on the bottom as a positive 4. Everything moves to the bottom because of that negative exponent. I'll go back to 16 in a second here. I'm going to do number 17 just because it's right in front of me. And then I'm not moving the board too much. So 8 over 6 becomes 1/2 or 0.5. Okay, so 0.5 times 10. Now the negative exponents are kind of confusing, so you can just switch them. Squared and then to the 1st. So 2 minus 1 is just going to be 1. So 10 to the 1st. Now this is not in scientific notation. 50 cents isn't good. Remember we talked about that being like a like lunch money. So I need to move this decimal over 1 time to be 5. If this number gets bigger, this one needs to get smaller. So it's 10 to the 0. Anything to the 0 power equals 1, so this just ends up being 5.
$5 for lunch.
You get a double lunch.
Oh yeah, true.
Okay, I'm going to go back to number 16 then, if we could. So now 16, again, I want this to be like lunch money size. So right now, it's smaller than a penny, so I need to move it over. So 3.46 times So we 10, but then think about it, really small numbers are those negative exponents. So we can go 1, 2, 3, 4, so a negative 4.
Why are you just singing all day when we do song?
Because it's funny when my kid goes stare at that.
All right, we're gonna go to 25 then. I think this is the next one.
And then the choir teacher goes, "Great, you have such a lovely falsetto voice." And you know that's not even fair. Yeah. And someone that was so soft and it wasn't even
That's Maddie's celebrity crush.
So in this case now, this negative exponent's got to get distributed in. Power to a power, we have to distribute that in. So this negative 2 is going to go in here. This isn't going to change right now. But now I would say to combine them the way they are. So basically, 3 minus 2 is 1, so a to the first. 3 minus 2 is 1, so a to the, or b to the first. And so you don't even need the first power. Now this one, we're going to be multiplying. There's no power to a power to worry about, so I'm just doing 4 times 7, which is 28. X to the third x is going to be x to the fourth. Y to the negative fourth and y to the second is going to be y to the negative 2. But then that negative exponent, I can't leave that where it is. I have to move it to the bottom. So that's going to go on the bottom.
What are you laughing at?
Okay. So 27, I have to distribute that second power in. So distributing that second power in, so negative 3 to the second, r to the fourth, s to the second. Okay. So negative 3 to the second is going to be 9. Now I can multiply. So 9 times 2 is 18. R is going to be to the fifth power, and S is also going to be the fifth because we add the exponents there. All right, I'm going to go to 40 then. So number 40 here, I have to distribute this negative 2 power in on the bottom. So this is going to go into all 3 spots here. So all those negative exponents. Now, since they're all negative, I'm just going to move them all to the top. So all of them, I'm just going to bump them up to the top. So I'm just going to, these were already there. I'm going to put these up on the top. They're all going to become positive now. So everything's going to be on the top of the fraction. Now careful, negative 2 to the second power is just 4. Negative 2 times negative 2. Then I have to multiply it here, so it'll be 8. A to the third, a squared is a to the fifth. B times b to the sixth is b to the seventh. this one is one I would simplify the inside first. So I would simplify what's inside of here. So 5/10 becomes 1/2. It's gonna be A on the top and then B on the bottom. It's all to the 4th power. So then I have to distribute that. Oops, 2 to the 4th, B to the 4th. So everything gets to the 4th power. Well, the 1 to the 4th doesn't change, it's gonna be 1. So 1A to the 4th, 2 to the 4th is gonna be 16. It's 2 times 2 times 2 times 2. And then B to the 4th. All right, 42. So in this case, that negative exponent can be distributed everywhere, so top and bottom. Oops. So A is a -2, but on the bottom it's going to be B to the 2nd, -2 times -1, and then this is going to move to the bottom. This will become 1 over A squared B squared. And then finally 58, thank you.
No problem.
So 58 is y to the 28 equals y to the 3r. Sorry. Let's see. 3r times y to the 7. All right. So typically what we do is we add these exponents. So this would be y to the 28. This would be y to the 3r plus 7. Normally we just add the exponents. This has the same basis. So we want to figure out, when does 28 equal 3r plus 7? So I move this 7 over, and then divide by 3. So r ends up being 7. What's that? No, it makes it hard, sorry.
Get
You can
ready.
take a notes break outside.
It's not too cold for you today?
What?
Yeah.
Yesterday you can sleep.
Yeah, you were so cold yesterday. I was perfect. I'm gonna put the jacket on.
You don't need the day 1. I'm hoping we can finish this in one day here. Maybe. Sorry.
Today's my aunt's birthday.
Happy birthday, Edison.
My Aunt Carrie, you know, it's her birthday today. Yes, you do. You all say about how hot she is.
I remember it. Because he gave me up.
What are you still laughing? I can't see it.
I think I'm just sitting there and
Okay.
Like the little girl that laughs at church.
Yeah, I do that.
Okay.
It's
So, if you recall, the other day we talked about terms are separated by addition and subtraction.
Oh, shoot.
So we're going to talk about polynomials today. So last couple of days we've talked about monomials, so single terms. Now we're going to talk about multiple. Poly is more than one term. So
Poly or mammies. Isn't that the relationship? Poly.
yeah, polyamorous.
Wait, really?
Yeah.
Yeah,
Was that?
Oh, dang. Yeah, I forgot that he was.
Yeah.
How could you forget?
Yeah, you guys harassed him all the time.
Yeah, he He was just such a presence.
Yes,
Yeah.
quiet.
He brought so much to our playing class.
He's coming back soon.
Jax, they're talking about you. Do you hear that?
No, we're not. We would never.
Okay.
He like zoned out when he's making his name.
We would like,
He's probably just kidding.
Somebody
You guys be muted. Okay. That'd be funny. Except it wouldn't be live, it'd be afterwards. But yeah, okay. So
Anyways.
we're done. Okay, so this is one term. This is called a monomial. Remember, if there's no addition or subtraction, it's considered one term. I tried to leave a little space. You probably have space in your column. I'm going to talk about something else that shows up in there as well. So once I add an addition or subtraction to this, so if I'm just going to separate this with a plus sign, it becomes two terms because of the plus sign. So 1, 2 terms. You know what that's called?
Binomial.
A binomial, like a bicycle.
and the next one is trinomial.
Yeah.
Oh. There you go.
Okay, Kinsey, you don't need to show off.
No, you.
She doesn't have a Kahoot today, though. Sure.
Oh.
Sorry, I got
You're just mean.
See you later. I gave you Pringles.
That's the last time.
Okay. So this is a trinomial. It has 3 terms now because it has 3 things separated by addition and subtraction. They really look the same except for those plus and minus signs. That's 3 terms there. Now, anytime it's 2, 3, 4, or 2, 3 or more terms, we can call it a polynomial. Now, these are more specific types of polynomials. So if I have like, so this would be considered like 4 terms. There's not a 4-term name one, so we just call it a polynomial.
Polynomial.
Now another thing they're going to talk about is something called the degree. So if you can kind of fit that in here somewhere, if you have room. So the degree, I don't know if I have that listed anywhere. Oh, I have it down on the bottom. Why don't we wait on the degree definition? We'll come back to that. So all of these are examples of polynomials. I want to talk to you guys about what makes something not a polynomial as well. So the things I'm going to list here are all examples of things that aren't polynomials. So if they have those and they ask you, is this a polynomial, yes or no, you can just say no. So a variable under a root. Oops, I can spell. So like, for example, the square root of x is not considered polynomial.
I was named after.
What?
A variable in the denominator. Oops. Would be considered not a polynomial. And then finally, a variable with a negative or fractional exponent is also not a polynomial.
Are you on team Gail or Peta? Yeah. Peta.
Yeah, he is the OG. He is that
Alright,
good.
so,
That's true.
a problem like this up here, so this that you see, one of the things to be comfortable with is writing something in standard form. And again, we did this in algebra. So standard form is when I write it in a specific order. And the order I want it to be is the highest exponent down to the lowest. So highest exponent to the lowest. Or to the constant. So what term would I write first? 2x to the fourth.
I'm blind.
2x to the fourth. Next now, Maddie, what should we write?
Yeah,
X to the third. Then
X
x to the second.
X to the second.
Then next,
to
5x.
5x.
And then minus 2 is the one without a variable at all. So that'd be considered standard form. That way everybody's answer looks the same. It's just a standard way to write things. Kind of like putting something in alphabetical order, but in math.
So 2x to the fourth is bigger because
The power.
the power is bigger.
Yeah, that exponent.
Okay.
Okay. So the next thing is the leading coefficient. So the coefficients are the numbers in front of the variable. So the leading coefficient is the first coefficient when it's written in standard form. It's like the line leader. Abby will get that. Line leader.
Yeah.
So it's the first coefficient
Yeah.
when in standard form.
So it's 2.
So right. So in this case, the leading coefficient would just be 2 in this case.
So smart.
All right. So so the point of knowing what that leading coefficient is something we'll use a little bit more later on. You definitely use it in pre-calculus and calculus, is knowing stuff about that leading coefficient, knowing the number of terms, that kind of thing is going to be something you end up using a little bit more later on. So classify based off the number of terms. How many terms does this have?
5.
5 terms. So then we call it a polynomial. Yeah, there's no good like nickname for one with 5 terms. Polynomial.
Wait, who said that? There's no nickname? It sounded like Nick.
It did sound like me.
And then you were like, that was bad.
It sounded like, but I can't hear.
I was just surprised either of you talked.
You know they don't know what to say.
Okay. Mean girls.
That did sound the same.
All right.
You're like, you're better than that.
So the thing that I want to mention is degree. I kind of wrote that up in our little chart up there. I didn't mention that before. We talked about degree in algebra as well. The degree is the highest exponents on the variables among all the terms. So the degree of this polynomial, what's the highest exponent?
4.
4. So this would be a 4th degree polynomial. So I want to go back and look at this chart on the top and talk about the different degrees. So this would be a 4th degree polynomial. And again, the degree is helpful as we move forward with graphing something like this. This is something we'll touch on in here, but we'll get more into when you guys get to pre-calc.
This is ringing bells.
So I want to talk about degree on the chart on the top. Hi. So the degree here, let's actually start from the bottom. What's the highest exponent here?
4.
So that'd be 4th degree.
4th degree burn.
Right, like just like a 4th degree burn, exactly. Thanks to relate that to something we understand. All
Something
right, working our way up.
7.
That would be a 7th degree polynomial. Very good. Up, one more.
7.
Also 7.
And same thing.
Okay, now this one's a little bit tricky, and this is one that's why I waited to do it last. 'Cause
It's only one.
all right, so it's only one term, right?
Oh.
Kinsey? So, but there's 2 variables. So it said the highest exponents on the variables among all the terms. So there's a 7, but this is the same term. So we also have a 3. So this would be degree of 10. This is kind of a strange one. That's why, again, I waited for last for that. So this would be a 10th degree polynomial because of the 2 powers there. And that we won't see one like that very often. It's kind of a strange circumstance, so just maybe make a little star there. Nothing like to be like, not going to be like there's 50 questions like that, but just that you understand that that degree can change like that. Okay, because I'm going to flip down to the bottom here again. So when we're adding and subtracting polynomials, which is what we're about to do, do you guys remember what we can add and subtract together? What can we combine? I always said the same thing in algebra. Yeah, you said it, and you don't even have any algebra, and Cassie raised her hand behind you, so. So we can only combine like terms. You guys obviously have heard that before. So you can only combine like terms. Now, when we add or subtract, we're going to add or subtract the coefficients. We're not going to do anything to the variables. So if I'm adding, like, so let me just show you guys a quick example, like 5x and 3x, that's going to be what?
8x.
8x. I add the coefficients, but you didn't change the x. Every once in a while I have a student that says 8x squared there. So the variable just stays, it kind of comes along. So don't change the variable. Now, like terms. So talking about like terms here, the x's are considered like terms. So they have exactly the same variable. They also either have the same exponent on the variable, or they could have no variable at all. So when you're ready, flip the page, and you guys want to look at some of those combining like terms problems. So simplifying the polynomials, combining like terms, 2 examples there. So the first one's asking us to add them, if you can see that. And so just like we just talked about here, we're only adding like terms, and we're using these steps here. So in a problem like this, it's asking us to add them. Don't let the parentheses scare you. The parentheses are just grouping them together. In this case, they're really not even all that necessary. So if you need to, you might need to distribute first. So we have to distribute it all. Is there any distributing to do here? No, there's nothing being multiplied, so we don't have to do anything. Now we can combine like terms, add or subtract if we can. And I kind of do steps 2 and 3 at the same time, is I do standard form right away. We will go outside. We can, but we just need to get.
I kind of want to do
Oh.
Oh, you got.
Betty, not
All right. What do you guys want to start with on this one? Yeah, I would start with the 5x squared, not only because it's first, but because of standard form. So I'm going to put the 5x squared and the negative 3x squared together. What do we get then? 2x squared, 5 minus 3, so 2x squared. Again, we just changed the coefficients. You don't change anything about those variables.
Shoot.
What next?
3.
Yep,
They cancel each other out.
they actually cancel. Negative 3 and positive 3 cancels. It becomes no x. And then I'm left with
4 negative 5.
4 and negative 5.
That was nice.
All right, so the ones down on the bottom down here, the next couple, they ask me to distribute first. We want to distribute before we do anything else. Be careful in this example over here, the 8m to the second. What's being distributed?
The negative.
The negative, very good. My algebra students would have totally fallen for that, but you guys are way smarter.
I know.
So well, you guys were those students. at one
Freshman
point.
year and so
Yeah.
offended.
So we're distributing this negative in. So we distribute that in.
Oh no.
And now we want to combine my terms. So I have my 8m squared minus my 3m squared, so that's 5m squared. Again, I like to do standard form right away, so I'm going to write that 2m next, positive 2m, and then just the negative 4. Standard form. I try to kill 2 birds with 1 stone there. All right, the next one, we can do some distributing. We're going to distribute the 5 here, and then what's next? Negative 2, very good, and then positive 3. Then we'll combine our like terms.
Oh my.
I'm going to put these two together first, negative 2, negative 3, so negative 5 into the second. 15 and 18, 23. And negative 20 and 3, so negative 17. We need a break. Okay, so we can take a break before we do multiplying. We'll go outside if you, for some reason, don't want to. I didn't have an activity planned for outside because I did have a Kahoot, and that's not really an outdoor activity. So we'll have to do the Kahoot another day, which is okay. But we'll go outside. If you guys, we can do a little walk, but if you don't want to walk, you can just sit in the grass over here, but it's up to you. I'm going to pause you guys because you don't need to go on a walk with us.